I'm building another whistle. These things are kind of addictive. I decided to build a 3-chime air whistle. I'm trying to replicate the ghost whistle. There's this real eerie sounding whistle, and I'm going to build these out of 3/4 inch copper pipe. The length for my longest whistle is 10 3/4. That's working length. That's from the languid plate to the end. That's what gives you your note. And the it's 10 3/4 inch, and according to all the theory in the tables, that should have given me a D. What it actually gives me is a D sharp, but that's okay. I like it. So the fundamental is a D sharp. But then it jumps up when you increase the pressure, and it jumps up to actually an A. So the notes I'm going to use for a key of D sharp to make my ghost whistle is D sharp, F sharp, and A. Rather than using an A sharp as the last note, I'm going to drop it one semitone to A. On the keyboard it sounds pretty eerie, it sounds pretty good. So anyway, what I've got, I built my first chime, and it's 3/4 inch copper pipe. This is a 90-degree mouth. It's called a 90-degree mouth. And the way I got that is that I traced out the piece of pipe on the paper, divided it in 90 degrees, and measured, and it turns out that the width is 9/16. And the cut up for a 90-degree mouth is equal to the diameter, so I've got the cut up here as 3/4 inch. And my languid plate in there, if this will show up, my languid plate is a nickel, and you can see the slit width. I went a little larger than my other whistle because I found out with like a 35 thousandths slit width, I had a weird screeching noise between the first note, the fundamental, and the next note, and I didn't like that. And I figured it's probably because the smaller the slit width is, the faster the air moves. Maybe the air is moving too fast, so I started widening it out. And then when I widened it out, this one is 45 to 50 thousandths, and that went away, and it made a smooth transition from the two notes. The outside diameter is actually 7/8. It's 875 thousandths, and the inside diameter is 820 thousandths. And the nickels are good because they don't rust or corrode. They are 835 thousandths in diameter. So I just file them down until they press in there, and then I mark my 9/16 width for my slit width, and then file that down until when across here I'm 45 to 50 thousandths less than the diameter. Then I line it up and push it up in there, and I use my socket because it's real flat to push it up in there, and it has to be dead even with the lower lip of the mouth here. If it's below, I've tried experimenting. If it's above it, you won't get any sound at all. If it's below it, you won't get any sound at all. It has to be right even with it, right level with it. So I got this one JV welded in there. I got a little JV weld around in there. And then I made this piece here. I'm getting a reputation as being the mad scientist of the Black Hills because of all this weird stuff I built. This is going to be what they call the bowl. This is where everything will come together. The way I made this, a mandrel, which is 3 pieces of steel, 7/8 steel tubing, same sizes as the copper tube. And I used a piece of my 1.5 inch left over for making the big whistle. I have this goes around here to give me to mark it for cutting it straight. And then I measured it into thirds and marked a line on at each third. And then at each third I measured 3/4 of an inch wide, and then I made 3 slots, 3/4 inch wide and one down the middle, because I bent these out. And I didn't, it wouldn't allow it to bend real good if it was full 3/4 inch wide, but 3/8 wide it does. And the thing about, then I annealed it. The thing about copper is it anneals totally different than steel. I heated the end of this up cherry red with a torch and went right in cold water, and that anneals it, makes it real soft. Then I used my pliers and I just bent these tabs out 90 degrees. This is 3/4 inch down here, and this is, I think, 1.5 inches. That's inch and a quarter here, because an inch of this will go in to my bell reducer. I'm going to use a bell reducer just like that, and this will go into that. And then I use my mandrel, put it on there, and I use the ball peen hammer to smash these down so they lay in there nice. And this will tie all 3 tubes together. I'm giving these rounded top mounts rather than pointed or square top. I think it probably works pretty good. The square tops work really well. A lot of whistles have that, and then the pointy tops too. But so I'm just trying this. I think it looks cool. I think it works good. So anyway, that's my D sharp. Now it's time to do what they call in pipe organ terminology, voicing the pipes. I can line up my mark for my F sharp, and I can mark this tube and cut it off and cap it, and it should give me my F sharp note. So now I have my D sharp, and my F sharp, and my A. That's going to be good. I like that. I got my whistle tubes on their base now. I got the tabs cut down, file smooth. Everything's all plastered up with JB weld, and it actually works pretty darn good. Finally got my parts. Got my bell reducer, 1.5 to 1/2, and my T, and that completes the 3 chime whistle. That's what I was after. Gotta love that whistle.